morning, everybody, and welcome to Azure Flash News. It is episode 87.
87 on this,
welcome to episode
the
87.
2nd of March.
Yes, it is the 2nd of March, and it is warming up,
Yes, it is.
which is great.
We don't have any lousy smirch weather, according to Homer Simpson.
Yeah, I mean, boy,
For the
last year.
misprinted calendars.
So last year, it was pretty bad this time of year.
Yeah. The rate
So-
now, absolutely. Yep.
It was
that's
just
true.
snowing and snowing and snowing, but thank goodness we're not in that right now.
Oh gosh, that's
Went
right.
skiing yesterday.
Right on.
It was pretty
Mashed potatoes.
pretty much mashed potatoes. Really was. It was kind of slow. You hit a wet spot, you kind of go lurching forward.
Oh, I hate that when you get sticky snow and your ski, or
Yeah.
your whatever, your P-Tex has a tendency to grab it, and yep.
But you know, it's spring skiing. It's all right.
Yeah.
Anyway,
absolutely.
So
you were
what's-
outside enjoying.
That's right. We were
That's-
outside. It was warm.
absolutely.
It was like it's hard to know what to wear because you're
Yeah.
like bundled up and you keep taking layers off and
Totally.
no gloves. Nobody's wearing gloves.
Wow.
It was warm.
Wow. Yes, it was.
Okay.
Yeah.
Enough about skiing.
Right on.
How about some Azure?
We've got some Azure today. We've got some good Azure today. We've got an express route capability that we would like to talk about. Some new
Some new
capabilities, some new VM capabilities.
Yeah.
An ability to ensure that only things that should have access to something should,
Otherwise known as security.
otherwise known as security.
Yeah.
And then last but not least, we'll go into a little bit of a demo that I've been working on or have prepared to show people some of the complexities about accessing secure storage accounts from an Azure service. It's not quite as straightforward as one might think.
Okay.
So
I'll ask
yeah.
questions about it when we get there.
Absolutely.
Okay. All right. So let's start with ExpressRoute.
Yeah.
I think most people know what ExpressRoute
Well,
is.
and if you don't know, basically ExpressRoute is essentially an MPLS extension to your existing network.
Mhm.
And what it does is it provides, I won't say more secure, and I won't say,
Sure.
more performance, but what I will say is dedicated connectivity
Mhm.
between you and an Azure region. Okay, so basically you provision an ExpressRoute circuit. Typically your connection is made at a colo or a meet me point, I should say, like
Fiber
Equinix
hotel.
or Fiber Hotel.
Megaport, or
Yep.
there's a few others.
Yeah. Oh gosh, yeah. I
They're
should
very
name
regional.
names. Yeah.
They're regional, and so
definitely.
you can find different meet me points per
Yep.
company or whatever.
Absolutely. And there's the network service provider, and I mean there's two types really.
Mhm.
There's the telco, and then there's the network service provider concept. I believe those are the two differences.
Yep.
But the point being is that you're no longer traversing the public internet to access your Azure services, and you can actually do private peering, which enables connectivity to the virtual network in an
Yes.
IaaS scenario. You
which
can
is
also
which is what people usually do first.
typical. Yep.
That's,
Yep.
that's mostly what it's used for.
Yep, and then you can also enable public peering, which basically says, even for Azure public IP addresses or public resources, I still want you to traverse the ExpressRoute
ExpressRoute.
connection. And there's BGP routing, and there's all kinds of other stuff in there. But in a nutshell, that's kind of what ExpressRoute is.
Yeah.
And basically, what we've done is we're allowing connectivity, and we're allowing enterprises basically to create virtual WAN backbones using ExpressRoute. Okay, so on-premises to on-premises connectivity. But when you hit Azure via ExpressRoute, what you're doing is you're now traversing our backplane. So we're keeping you as I always throw out numbers, and every time I throw out a number, I see a different number. So according to this particular article, I believe there's 133,000. What did I see? Up at the top there, 130,000 miles of terrestrial and subsea fiber. Okay, across 6 continents. So basically, what we're saying is, if you're using this Microsoft Global Network, if you're using our backplane, and if you're using these ExpressRoute global reach, what happens is you're routed from your on-premises location to that Azure region. Then you're going from Azure region to Azure region, basically, or
Yep.
hubs, network
Yep.
hubs.
Yep.
And then from that hub, then you're back to on-premises again, maybe in location B. The cool part about this, though, is you're traversing our backplane. So you're not traversing the public internet in a traditional wide area network setting.
Yep.
Or you're not using VPN over IPsec.
Yep. And so then basically the Microsoft network becomes your WAN network.
Exactly.
Yeah. And so for a company that wants to reduce their telco presence and kind of put that more on in their management area with Azure,
Yep.
you can certainly do that.
Well, and the nice thing about this too, though, is it gives you more of a dynamic WAN, right? So when you think about a traditional, kids got to clap my hands here.
Don't clap your hands.
I know. If you think about a traditional WAN, it's relatively, I won't say static, but changes don't necessarily happen real fast. Whereas with this technology, it can be a lot more dynamic. It can be a lot more configurable in terms of different hubs, different locations that you're connecting to. So in that respect, I think that there's some flexibility here in regards to how you approach this on-demand kind of connections, that kind of stuff.
Yeah, and I think that to be completely frank, I think that this kind of model will fit some customers.
Yeah,
it won't fit other customers.
No, of course.
But really consider your strategy around WAN connectivity.
Yes.
And for the right customers who maybe, I'm just sort of speculating here, but it's possible that smaller customers but still have a global footprint that need that connectivity. This might actually make a lot of sense.
Absolutely.
Because it's a way for you to take advantage of our cloud scale. So anyway,
and that's a really big point, right? So we take care of redundancy. We take care of the larger global infrastructure investment, right? Yep. When you think about the 130,000 terrestrial and deep sea fibers and the scale out requirements, right? So this basically gets you out of the infrastructure business of having to manage all that to deploy, maintain, upgrade, et cetera, right? That's a huge undertaking.
Yeah.
Right?
You just don't have to worry about it.
No, exactly.
And you can partner with Microsoft to do that if you want.
Yep, exactly. So very cool.
Very cool.
Yeah, I'm a fan.
Yeah, the whole idea of using SD or software-defined networking, that area is getting bigger now. It's starting to include this sort of data center to data center connectivity that you wouldn't have considered before. So
totally,
software is eating the world, as they say.
Yeah, well, and the thing I like about this solution is it's not a one-way solution, right? It's not a Roach Motel where the connection is only from on-premises to Azure, right? This is on-prem to Azure to on-prem. Yeah. So unfortunately, the Roaches have an exit strategy.
Yeah, in this case they do.
But again, the whole point of this is we're not really relegating, or I shouldn't say relegating, we're not restricting you to one-way traffic just to pull you into Azure. It's go to Azure, find your exit location, and go back to on-prem. So that to me is really cool.
Yeah, pretty cool.
Yeah.
All right, so we have, I don't think this is an announcement, but it's still worth mentioning. It's just kind of like, hello, if you weren't paying attention, there's
Well, it is. These virtual machines are now available.
Yeah, right? and oh, is it? Okay.
Yeah.
So it's, it's now generally available. Okay.
Yep.
So, but I think also the other side of this is they're just pointing out the raw power.
Oh, exactly.
Of these machines, it's like, we GA things all the time, new VM types, but it's like, can you just pause for a second? Yeah. Check this out. You guys have got to see this. So they're really trying to call out the power of these.
No, what's fascinating, right? So 200 gigabit per second HDR InfiniBand connectivity, right? So that's ridiculous. So Azure is the first public cloud to feature this 200 gigabit per second InfiniBand and it's from Mellanox.
Yeah.
So basically what we're talking about latencies as low as 1.5 microseconds. Okay, so that's 200 million messages per second per VM. Think about that. That is nuts.
What do you do with that? I don't even know.
High performance computing.
HPC. What do you do with that?
It's amazing, right?
I know. Minecraft.
Yes. No.
Minecraft.
Bitcoin mining.
I wasn't going to say it.
I know. Mining. You should have just said there's a mining technology. Well, and so the other thing too, though, is so there's drivers that support remote direct memory access, or remote direct memory access, so RDMA, verbs, and MPI variants. So it's really cool that not only are we giving you this capability, but you're doing memory access, you're doing a bunch of other things, which is common in the HPC world, like RDMA or SRIOV. That's part of the technology around the connectivity, right? So the network availability.
Yep.
But it's amazing, right? So each of these machines, 120 AMD EPYC 7002 series CPU cores. Ridiculous. So 340 gig per second memory bandwidth, right? Which is nuts. Up to 8 single precision teraflops.
This is what I
want. Double precision teraflops.
This is what I want to use for my development box. Let's now Visual Studio Code on there.
It's nuts. So think of weather forecasting, weather forecasting models and stuff. These are workloads that you're not going to solve like with traditional HPC clusters. This is the top of the top, right? I mean, it is pretty amazing.
You know, these HPC workloads oftentimes scale with the latency of the network connectivity.
Okay.
So in other words, I mean, we know, I don't even know whose rule this is, but the number of edges in a network increases with the square of the number of nodes. I think something like that.
Yeah.
But anyway, it's geometric.
Yep.
And so as we increase the number of nodes in our cluster, the ability to move data across the network and for these things to exchange data becomes the bottleneck.
Critical. Yeah.
So this is why in these scenarios, this is why we need, not only do we need the CPU processing, so that's there, but this InfiniBand with latencies of 1.5 microseconds, speeds and feeds. We love speeds and feeds.
Speeds and feeds, that's right.
The reason why it needs to be that low is so that we can actually get a lot of data across the network.
Oh, absolutely. So, well, and this example is really cool, right? So this weather forecasting version 4 sim, right? So Cormac Garvey, they're part of the HPC Azure Global team. They've gone ahead and they published a guide to running this particular simulation on these VMs, right? So it's a 371 million grid point sim. So Hurricane Maria, remember Hurricane Maria? There was a Cat 5 storm, and it hit the Caribbean in 2017. So they're using that as their benchmark, and it's got a resolution of 1 kilometer, which is I mean, it's pretty significant.
Yeah.
So when you think about this, so these graphs are pretty impressive, right? When you talk about the speed up relative to a virtual machine, the number of VMs as it goes up to 672, but you can kind of see it fall off too, which is interesting, right? Yeah. It's almost like at a certain point, there's a lot of diminishing returns.
Right. Right.
So super cool. I mean, these are.
Oh yeah, here we go. Okay, so I'm looking here. Yep. If you're watching the video, I've kind of brought up the speed. So in other words, it really picks up after 64 VMs, but by the time we get to 640, you can see it kind of like that, and that's when the network, the effort to spread out the data and pull it across the network becomes more challenging. It just doesn't. You just can't get it, but you can speed it up. What is it? Almost what looks about 480 times.
Yep.
Compared. Yeah. So it's pretty linear. It's linear across here.
Yeah. 100%.
256. It's pretty much 256 looks like it's pretty linear. But then when we get to 512, it starts to drop off, and then 640, it really drops off.
Yep. So I think that again, it's interesting though that they show kind of there's this, and this is it's cool that we're not saying hey, but I mean at the end of the day you are seeing a 482x speed up over a single VM, right? Mm-hmm. But what I like about this though is we're saying, look, at some point it just doesn't make any sense anymore. You know, don't waste money on provisioning more resources because it's you're just gonna hit that limit.
Wow.
I know, very cool, right?
And then there's another fluid dynamics.
Oh yeah. Now that one is interesting too. Look at just that one.
That one has you don't really quite see an end in sight there.
No, that one is pretty impressive.
Yeah, I mean it is starting to fall. You can see the scaling efficiency starting to fall, but it doesn't fall off like a rock.
No. I mean, you're right. It definitely dips, but
it's just
so really... the I/O. So extreme HPC I/O meets cost efficiency, which is interesting, right? So, from a cost perspective, basically, again, here's a scenario where take this solution, run your models, and maybe you've got a big footprint, but shut it off, right? I mean, the whole point of this now is you're back to consumption on demand and only when you need it, right? So it's operational.
Yeah. It's, let's just say these things are fast.
Yeah.
Can we just sum it up by saying these things are fast?
Yeah.
So if you have an HPC workload, you gotta stop and think, really, should I be doing this on-prem?
Right.
Or should I be doing this in the cloud where if you do, maybe you could figure out a way to scale it up and scale it down when you need it.
Absolutely.
Turn it off. I mean, that's kind of the whole idea, right?
That's totally
it takes work.
Well, of course.
It takes work. You've got to figure out how to do that. We've spent time figuring out how to do data centers and how to make those work as efficiently as possible. So there's going to be some work to make the cloud work for you.
Absolutely.
But the money savings are
fantastic.
Probably there.
So, absolutely.
Yeah, that's
so really very cool. I mean, a very interesting article. When I started seeing some of these numbers, I went, wow. Just like, wow.
Yeah, that's crazy. That's
absolutely.
Crazy. Good call out.
Yeah.
Okay, so Azure Virtual Network Service Endpoint Policies.
Yep. So for those of you that don't know, service endpoints gives you the ability to create a secure connection, right, for certain PaaS services from this multi-tenant environment into basically into a virtual network, right? So you're creating a service endpoint connection, essentially, and assigning that connection to a subway or a subnet, not a subway, a subnet.
Yeah.
Details, right? And now basically what you can do is you can do access restriction. Okay, so it's different from, we'll talk about private endpoints probably next time. So it's different from a private endpoint. But at the end of the day, the service endpoint allows you to essentially block connectivity, say, to the public internet, or restrict access to, like I said, a virtual network or on premises. What we've done, though, is we've taken that a step further, and we've enabled these virtual network service endpoint policies feature. Okay.
Yep.
So what that does is, with a service endpoint connection to your VNet, we're basically saying, okay, so for this subnet, here's basically, and I should say, carte blanche access to the storage account, right? But what we're doing is we're incorporating it, taking that a step further, and saying, here's these endpoint policies that you can actually more granularly restrict access to these particular storage accounts.
And so what I'm hearing is that when you set up service endpoints, just service endpoints, in this subnet, so I'm referencing the screen here, but if without the policy, so if I have some subnets and I set up a service endpoint, by default, both storage account A and storage account N will get accessed across the service endpoint.
Correct.
Which is great.
Yeah.
But if I actually wanted to deny access to a specific service, because these things are multi-tenant, so it's at the outset, in the beginning, think version 1 of service endpoints. We didn't differentiate between one or the other. We just said all of the routes, and this is all done by BGP, all of the routes for the storage accounts that you need access to, all of your storage accounts, all of those routes will be provided to you in your subnet. So that way you can close the IP firewall on your storage accounts, and the traffic can still a thing. But that meant that there wasn't a lot of granularity in what you can and can't access.
Correct.
This policy adds that.
Yes, it does. So this to me is a great enhancement, I would say, right, to the service endpoint concept. So you've got allow policies. You've probably got not allow, you've got data allow, or actions, not actions, data actions. So it's really important, I think, to keep working on this level, fine tuning. And I think that's the message here is, yes, we started with service endpoints and it's a great capability, but we're continuing to extend the promise of security, right? When we talk about, these service endpoints and really controlling access, because that's, I mean, if you can't control access to it, then really what's the point?
Yep, that's right. So, it's an ever evolving pathway on these private connectivity strategies. So if this is something that you're looking to do and you want to continue to lock down and narrow that access path, then this is a good way to do it.
It's a great way to do it.
If you're using service endpoints, you can do this.
Absolutely. It's a great way to do it.
Yeah, so we really continue to have private link, private IP addresses on your virtual network, but we also have service endpoints. So there's going to be kind of a dual strategy here for these different connectivity models to allow you to do that. I mean, we don't have private link everywhere yet, but service endpoints we have most everywhere.
Yes, very true. And actually, this segues into a really interesting kind of use case that I'd like to cover.
Yes, go ahead, Rick.
So awesome. So with service endpoints, or with these capabilities, we have we're afforded the ability to control certain attributes or certain aspects. So, for example, we can, if I scroll through here,
thank you, Emily.
If I can scroll through here, what's going on here? I should have 9 of 9. Why am I not seeing my scroll bar?
I don't know.
Interesting. Let's just refresh this. Just to be safe.
Maybe even refresh your whole browser.
And we'll go here. There we go. Nope. Interesting. So I might have to adjust a little bit of Baby Yoda.
Oh, Baby Yoda.
So let me just go ahead and hit my display settings here. And whoops, wrong one. Oh, there we go. So I've got Ooh, I'm a little nervous because I don't want to. Oh, we'll get a shot and see what happens.
We'll get some bars, but that's okay.
Yeah. Go to 200, get it up a little bit.
So we're definitely going to want to focus in on Baby Yoda.
Oh yeah,
you got the small.
So we can do a little bit of zoom action. So I have a resource group that basically contains some resources that I've been doing a little experimentation on. So
yeah, I see some logic apps, I see some storage, I see some web apps.
Yep, exactly. So what I've done is I have a logic app that's actually interacting with storage accounts that I've got the security connections to. So if we look at, what I've done is I have a dummy VNet, and that dummy VNet then is connected to these storage accounts. So you've got firewall and virtual networks, right? So in this case, I've got it hooked up to the virtual network. Obviously, I've got some IP connections. Otherwise, I wouldn't be able to see the storage account from my laptop. And you can see down here exceptions. So I've got this checkbox that says allow trusted Microsoft services to access the storage account. Well, okay, that doesn't just, so that's not akin to the way we used to do Azure SQL databases, because you would check that box and essentially anything that was running on the Azure network would have access to that resource.
In other words, that was basically a whitelist of all of the Azure IP addresses.
Exactly. So this is actually different. What this means is there are different, so you can see allow trusted Microsoft services. So there's
kind of a repeatable.
I know, it really kind of is, but there's two different ways.
But it takes you to the link. This is what we care about here.
This is the important part. So resources of some services when registered can access your storage account in the same subscriptions for select operations. Okay, so writing logs, backups, but very restricted, very limited access. Okay, so you can see Azure Backup, of course, Databox, et cetera, et cetera. So there's a list of the services and what they can do. And now there's the second section right here. So you can see container registries, Azure Data Factory, and Azure Logic Apps. That's the one that I was concerned about. Okay, because I've got a Logic app, I've got these storage accounts secured, but I want to be able to talk to them.
Right.
Well, by checking that box, I still have to assign a role-based access control role, an RBAC role, to a system-assigned managed identity. Okay. So what I did was I took my Logic app and I gave it a managed identity.
Okay.
All right. And the thing that we run into,
and just so that people, I'll just really quick while you're navigating. A managed identity is basically an Azure Active Directory principal.
Correct.
That is tied to and is kind of synonymous with the resource that it represents.
So it follows the life cycle of that resource.
Right.
If it's a system-defined managed identity.
System-defined.
And that's why I'm specific calling that out.
Yes.
It will go away when you basically tear down that resource.
When that Logic app goes away?
Yep.
So does its
managed identity. A user-defined managed identity actually stays around.
Right.
And because you may have used that user identity, which I don't necessarily recommend, but you may have assigned that to multiple resources.
Right. In other words, like the one scenario I think of that makes a lot of sense is if you have a cluster of VMs and they all need to access this resource.
Exactly.
And you don't want to have, let's say it has a cluster of 6 things. You don't want to have 6 identities to keep up with. And if you add a 7th one and get another one,
correct.
You just want to continue to assign the exact same managed identity to all 5 of these VMs.
That's where it makes sense.
It makes a lot of sense in that scenario.
Okay, so based on that, so I created my system-defined managed identity. I gave it the appropriate RBAC roles. So, for example, in this storage account, I'm pulling.
Can you show us the RBAC in that storage account?
Yep. So
we should be able to see the
managed
identity. Right?
In this storage account, what I'm doing is I'm actually reading an ARM template. Okay. So you can see in access control and role assignments. Here's my storage account. So I literally all I'm doing is reading a file. So I gave it. Storage blob data reader.
And look at this, I love it. It even says that it's a managed identity, and it shows you that it's a Logic app.
Exactly. Okay.
Yeah, that's cool.
So in that case, it's just reading those.
So this is the what is it? What is it called? IAM.
IAM.
The
Identity Access Management.
Yeah, right. The IAM list. For this container, showing us that the Logic app's managed identity, you've given it data reader role, or whatever it was, data reader.
Reader. So storage blob data reader.
Oh, yeah, because it was getting an ARM.
Correct. Now, what it's doing to this storage account is you can see nothing up my sleeve here. There's no containers. Okay. So what it's doing here is it's actually going to be creating containers. Okay. So I had to give it a different set of permissions. Now, what's interesting though here is because of this, the way this scenario is set up, I'm mixing and matching the type of API connectors it's using. So I am actually using a specific service principal that's assigned. You can see it's got contributor rights. And the reason I had to use a service principal here instead of a managed identity is because the API connector for the logic app will only use a service principal.
Okay.
Okay, so these are some of the caveats I want to call out here.
Yeah. I mean, this is evolving.
Yes. So if we go and look at that logic app now, call sec storage, which is call secured storage, I'll go ahead and I'll show you what's happening. So you can see I get an HTTP request, right?
Right, that's your trigger.
So I'm doing actually two different things. So I was testing different paths. So in this case, I'm reading a blob, right, from a URI, and I had to identify, in order to do that, I had to give that step authentication. I should say authorization.
Yeah.
So if I go back here, and if I go back to, I'm just going to go to my, just to show you, give you a better idea. Yep. So we're going to go in and we're going to edit this. So read blob. What I had to do was use manage identity, and I gave it an audience of that storage account. Now, you're probably asking yourself, why didn't I use the built-in API action to read a blob? The problem is it doesn't support the managed identity concept. Yeah. So I had to actually use an HTTP action to read the blob so that I could set the context of the authentication type to the managed identity, give it the system assigned managed identity associated with the logic app, and then scope the audience. Now, in this case, though, I could use the built-in action for create or update a template deployment, okay? But what you'll see is, so I've got my subscription, so I'm actually reading in the template content, right? The blob content. But down here you can see connected to service principal. So this step requires either a service principal connection or I could run it under the context of my account, which makes no sense.
Well, yeah. Keep going.
Right. Whoops. Whoa. Hey, how you doing?
Zooming.
So in that path it does that. Okay. Now there's another path where I can follow where I can actually, instead of doing read blob, there's another path that I can take where it will. Whoops. I don't know where I lost that other step, but that was interesting.
Yeah, that was the edit. It looks like you changed it, but down here you had it.
Yeah. So if I go back, you'll see that there's actually two paths. So I took out the second path for now and just followed this path. And then of course I'm giving it a response. So now that I've got all my permissions set up, I've got the service principal that has the ability to write to that second storage account. It's actually using the Azure management backplane, right? So it's hitting the management API. So if I run this, you'll see what happens is it's going to perform the action. It's going to run under the context of either the managed identity for those HTTP actions or the service principal for the ARM template deployment. And you can see read blob. It's,
Rick, what do you think of the chances that if you change the ARM deployment from the ARM deployment task to just an HTTP post to the ARM API?
It doesn't work. So
using a managed identity.
So you're saying if I use this step,
instead of that step, use an HTTP post and use managed identity. But anyway, keep going.
Well, if I were to use an HTTP post, then I would probably use and I actually had that path.
Yeah.
Okay. So you can see it stepped through and it went through and it did everything. Okay. Great, so this step was successful.
So just at a high level, once again, we created, can you minimize that one?
Yeah, of course.
So we can see the whole thing?
Yep.
Okay. So we started with the trigger. An HTTP trigger doesn't do anything. It's just how it's triggered. You read a blob,
the content,
which is an ARM template off of a storage account.
A secured storage account.
A secured storage account, and you used a managed identity to get to it.
So
that only you gave this logic app permission to read that storage account.
Correct.
And that's it. That container, actually.
That container. I scoped it down because I wanted least privilege access.
Right. And then you turned around and you deployed something with it.
Correct.
And so in some ways, this example is maybe a bit arbitrary, but the point is that you can use managed identities plus IAM RBAC to really scope down and use these managed identities to access.
And the important thing here is, the important thing here is whether or not you're using a secured storage account where it's connected to a VNet. To me, this is how you should approach this. Scope these permissions. In fact, so in this case, even I'm using a service principal for this step for create or update a deployment. If you go back and look at, so if I go back to my overview and you look at some of my legacy runs here, we'll see this one. I think it shows. Nope. One more. Yeah, probably down here, I think. Yes.
There we go.
So you can see here, instead of giving this a service principal account, like I can actually do this.
Yeah, I wondered about this.
Right? Where I can still use, if I scroll down here, well, you're not seeing it, unfortunately.
You can't see it.
I can still use the managed identity, and I can scope it to basically a scope down contributor role for that storage account to provision containers.
So you were able to demonstrate both options.
Correct.
One is using the task from Logic Apps that creates an updated template deployment, which requires service principal.
Yep.
But you also did the same thing using management.azure.com and hosting using managed identity.
Correct.
I like.
So the whole point is, like I said, don't carte blanche give access to anything, right? Now,
and another thing I want to say, I'm just going to mention one more thing.
Please.
This is like, we talk about zero trust, and it's kind of a new buzzword, but zero trust basically means it's not about firewalls, it's about identities.
Exactly.
So firewalls are great, private connectivity, I don't have a problem with that, but it's kind of irrelevant. What we're really trying to do is make sure that we connect to known endpoints with known identities on known
permissions.
With known permissions.
With very specific permissions.
And so now we're saying, like, we don't really even care that this is public, it really shouldn't matter.
No.
Because the only thing we gave access to was this managed identity. In this Logic app has access to the storage account, and that's it.
And that's it.
That's it. And if you said, well, but what if somebody went into the storage account and just opened it up to the world? Don't allow that.
Don't allow
it.
In fact, you should have a policy.
Yeah, just don't allow it.
That prevents that.
Don't give people access to the portal.
Right.
Make them go through a
command line interface.
Or something.
Or a CI/CD pipeline.
Yeah, CI/CD pipeline.
Or some other way to do it where you actually provision via, and then you control the layout, the access policies, everything else via blueprints and policy and all that stuff, right? So anyway, I just thought it was interesting because you can still create a secured storage account. You can firewall it and block it and do all these things, but when you have to use something like a Logic app, there's still a path forward.
That's right.
My suspicion is that in the future, the API connections will support probably more of the managed identity type of scope. So that you'll be able to use the built-in actions instead of having to drop down to an HTTP action and then do a REST API call. But for now, this is absolutely a very reliable, very secure, very well-documented way of doing things.
Yeah. That's awesome. I love it, Rick. Nice work.
It's all good.
Nice work.
So that brings us to the top of the...
Yeah, and I was just saying, we were just kind of talking before the show about how the fact that we have these silos documented, but kind of pulling it together and saying, we've documented that you can do managed identity in Logic app. We've documented that you can connect via this secured, trusted, whatever. But kind of putting it all together. Hopefully that's what we're able to help you do.
Exactly, and that was, quite frankly, I'll be honest with you. I spent a fair amount of time finding all the nuances. Like I thought, just create an API connector. That didn't work, right? And so I had to go back and go, okay, what's missing here? So yeah, it was a process of elimination, but anyway,
nice job, Rick.
Yeah, if there are any additional questions or if there's any follow-up or if you have any feedback in regards to that solution, I'm happy to respond. Feel free to reach out to me at rick@microsoft.com, or of course, you can always message us at Azure Flash News in our Twitter account.
Yeah, and if you want to catch me, you can catch me on Twitter at mgarner, or feel free to email me, mgarner@microsoft.com.
Absolutely. And thank you, of course, to the MTC.
Yeah, thank you to letting us be in the Envisioning Center to host the show. We really appreciate that. We couldn't do it without that, and we couldn't do it without
Emily McMiller.
That's correct. Who produces the show for us. We really, really appreciate it. We absolutely could not do it without her.
No, without a doubt.
Emily.
Thank you very much. And we do have, so we are winding down. We've got a few people that have been posting tweets with the hashtag, I think it was Cloud Socks or Azure Socks. I can't remember what it was, but so we do have a few tweets that we're going to be able to pick a winner from probably towards the end of this week. We've been getting some good feedback. So really appreciate your time tuning in either to the YouTube channel, to the Stitcher channel, to the Google channel, to the iTunes channel. I mean, we've got lots of communication syncs for the podcast, but regardless of how you tune in, we really appreciate it. So until the next one's published.
Which should hopefully, although you wouldn't know this on this thing, hopefully it'll be in the next half hour.
Yeah, right on. Minutes. So until the next time, obviously keep your fingers on the keyboards and your head in the clouds.
Thanks, everybody. See ya.